Hey guys, we are looking at two sets of numbers and we want to know if they are Pythagorean triples. When we're talking Pythagorean theorem, we probably think right triangles. So basically what they're asking is, could these three lengths be the sides of a right triangle? So to figure this out, I just need to use the Pythagorean theorem. I'm going to plug in these numbers and see if it comes out equal. So the first thing I need to do is figure out which of my numbers is C. That will be the longest side. Now, when we don't have square roots, it's not too hard to figure out what the longest side is. But with the square roots, we kind of have to think about it for a second. So the square root of 10, you could plug that into a calculator. Or I know that the square root of 10 is going to be somewhere between 3 and 4, right? Because 3 times 3 is 9. 4 times 4 is 16. So it's gonna be in there closer to the 3 range, but it's gonna be somewhere in there. Now, 3 square roots of 7, I know the square root of 7 is somewhere between 2 and 3, right? Because 2 times 2 is 4, and, oh, I almost wrote 4. And 3 times 3 is 9. So it's somewhere between 2 and 3. Then if I multiply that by 3, 3 times 2 would give me 6. 3 times 3 would give me 9. So this number is going to be somewhere between 6 and 9. So both of those are less than 13. So guess what? This is my C because it's the longest side. And then these are the A and B. It doesn't matter which is which. Now I'm going to plug this into the Pythagorean theorem. A squared plus B squared equals C squared. So we are going to take the square root of 10 and square it. There's my A squared plus B squared. So plus 3 square roots of 7 squared. The reason I'm doing the parentheses is so you know that the squared goes to the whole thing, okay? And we are going to see if this is equal to 13 squared. I usually like to put a little question mark here to remind myself I don't know yet if these are equal. That's what I'm checking for. All right. Now we're going to do some work with some square roots. If you're not super familiar with square roots or you need a review, I will link videos as I'm talking about it if you need more in-depth examples. So when I have the square root of 10 squared, my squared and the square root cancel each other. And guess what? I'm just left with 10. Isn't that nice? Oh my gosh, best day ever. Okay, then we are doing plus 3 square roots of 7. So I can kind of think of this as the squared goes to the 3 and to the 7. So 3 squared gives me 9 times 7, sorry, not 7, the square root of 7 squared. Again, the square root and the squared cancel, and I'm just left with 7. Those are being multiplied, and we're still seeing, is this equal to 13 squared? Which 13 squared is 169. Okay, next I'm going to multiply these guys. So I'm going to have 10 plus 63. Is that equal to 169? And you're probably seeing that this side is going to end up being 73, which is definitely not equal to 169. So are these three numbers a Pythagorean triple? No, they are not. Okay, let's go ahead and check this other side. We've got 6, 3 square roots of 5, and 9. So again, let's figure out which one of these is the longest side, or C. We've got 6, 3 square roots of 5. Let's see, I know the square root of 5 is going to be somewhere between 2 and 3, right? Because 2 times 2 is 4. 3 times 3 is 9, so definitely closer to the 2 side. And then if I multiply that by 3, I get 3 times 2 gives me 6. 3 times 3 gives me 9. So somewhere between 6 and 9 is what this decimal will be. It's not going to actually be 9, right? Because we know the square root of 5 isn't 3. But it's going to be somewhere in between there, which means 9 is my longest side. So C. And then these guys are A and B. It doesn't matter which is which. All right, then we're going to plug it into our Pythagorean theorem. So we get a squared, so 6 squared, plus b squared, so 3 square roots of 5 squared. And we're seeing, is that equal to c squared or 9 squared? All right, 6 squared gives me 36 plus, again, I can give this squared to each of them. So then I have 3 times 3, which gives me 9, times the square root of 5 squared. Those cancel, and I'm just left with 5. Is that equal to 9 squared, which is 81? Okay, next I'm going to multiply these, so I'll end up with 36 plus 45. Is that equal to 81? And when I add 36 and 45, guess what I get? 81. So I end up with 81 equals 81, which that is definitely true, which means these 3 numbers could be the sides of a right triangle. So are they a Pythagorean triple? Yes. All right, I hope this helped. If you need some more examples, I will link a playlist for you. Thanks.